Hey, Keeney coming to you with another case study. So we've got this '02 Grand Cherokee behind us, and the customer complaint is the vehicle will start and stall. It will stall within 10 seconds of running, typically, but it'll run a little bit longer when it is cold. So I was able to jump start it and get it pulled in the shop. It was misfiring a little bit and not running great. That was also a complaint that it would run rough before it would die. It wouldn't just cut off. It would spit, sputter, stumble, and then eventually it would die. So a little bit of history from the customer on this vehicle. It has had uh, it's unclear if it is set in crank sensor codes. All I've done is, like I said, jump it, drive it in the shop, and I got a battery charger on it. So I don't know if there's gonna be any codes in it or not, with the battery being totally dead when I got to it. But in any case, I think somewhere there was a crank sensor code in this vehicle, and they have put four different brand crank sensors in it, and none of them fixed the issue. But none of those brands that they had were a Mopar part, and I think these things are pretty sensitive on needing an actual Mopar part. So that's one. So four different brands didn't fix the issue. Cam sensor has been replaced. The coil pack assembly and like boots have been replaced with plugs. PCM has been replaced. The oil has been changed. Uh, they were inspected some wire harnesses. Didn't see anything there. And then a note from the last guy: runs better when cold and uh, gets worse after warm up. So, in a couple, just getting in here, I do a normal check on vehicles before I actually start into the diagnostic. So, a couple things I did find where there's a little bit of aftermarket wiring underneath of the hood and a little bit of rodent evidence on the valve cover. And one kind of odd thing, when I turn the headlights on, not the parking lights, but when I turn the headlight switch on, the engine fan comes on. Well, it doesn't matter if the key's on or off. It looks like some of the aftermarket wiring may have gone to the fan, but yeah, that's what I know about it so far. I'll walk this camera over there. I can show you some of that aftermarket wiring, and then I'm gonna grab a scan tool. We'll plug into it and see if it has any stored codes. Like I said, I don't really expect it to have a whole lot in there, but we'll plug in and see what we get with it. Over here in the engine bay, this is the aftermarket wiring I was talking about. Looks like there's a relay dangling down there, and we can kind of see it goes to what may very well be, it looks like the fan switch. So perhaps this is fan controlled. I don't know. Battery does look new, but like I said, it was dead. And then back there in the valve cover area, there's a little bit of rodent looking nest stuff. I don't see any wires too chewed up, but yeah, this is where we're at. So let's go grab a scan tool and plug her in. Got the tool hooked up, got some codes and modules. This is pretty cool. Apparently the body controller has no code listing, but gives a code description. I don't know if that's an auto glitch or what. I kind of assume it is, but body controller has coolant switch, fog lamp, which this vehicle doesn't have fog lights, and then please refer to service manual, whatever that is. ABS has some stuff in it, but nothing that I see is going to, got a low voltage code, but nothing that I see is going to keep this thing from running well. And then a compass code, nothing in the engine controller, and nothing in any of the other modules that were picked up. So I think we're going to look at some live data and see what happens when we start it. So just looking through the data pads and trying to figure out what I want to record. A lot of times for drivability issues, I actually like on cold starts, which this is because it hasn't run much other than to drive it in an hour ago or whatever. I like to watch oxygen sensors as they warm up. I like to see them, be high for a second and then come down as the heater comes on and then start switching. Right now, key is on, engine is obviously off. I haven't started it yet, but I'm already seeing an interesting reading. So 1, 2 has a voltage of 484. and the rest are 5. I don't remember. I know Chrysler does weird bias voltage stuff on their oxygen sensors. I don't remember what it is off the top of my head, but just something I noticed that that one's different than the other. But what I'm gonna do is graph merge these and then see if I can zoom out a little bit and make this go slower. Yeah, we'll do it like that, and then just see if it'll start and run. So it's running a little rough, kind of like it's surging. And now there's some weird whistling under the hood. That's kind of weird. Now the whistling's gone. I wonder if this thing has an air pump. So it looks like red and blue are coming down. So those are both upstreams coming down from 5. So it is misfiring, but not every revolution. It's kind of like doom, 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 and something keeps whistling. So right off the bat, this tells us high probability our oxygen sensor heaters are working. I don't know if you can hear that whistling in the camera. I have no idea what it is. I wonder if it's an alternator or something weird. We'll keep that in the back of our mind. Either way, with all this, looks like oxygen sensor heaters are working, so that's a good sign. I'm gonna watch this for a bit, and then I'll bring you back. Okay, so we now have a straight misfire, and we can see all the oxygen sensors went low. So I don't know what cylinder is cutting out, but when we have oxygen sensors go low like that, typically that happens with a straight misfire as we get all that lean pulse going through or past the sensors. Uh, but yeah, so this is interesting. I'm gonna check some more data now and bring it back. All right, so went ahead and shut it off because it was straight misfiring and hit trouble codes. We got 2 codes now. We've got ignition 1 coil primary circuit and no cam signal at PCM. So I'd say this is probably going to be a good place to start. I may start this a couple more times and clear this and see if it comes back right away and see if I can get it. It is interesting in the beginning, like it's just an occasional miss. It's not like a dead hole. It would run fine. I'll call it, 2, 3, 4, 5 revolutions and then miss, and then run good 2 revolutions, miss, and then so on and so forth. But when we saw those oxygen sensors drop out to super lean, it was a dead miss. So it sounds like, it kind of feels like one. It's hard to tell, 1 or 2 cylinders. If I remember this inline, so it's inline 6 4-liter. It's got 3 coils on it that are all part of one pack. So if this is going to be indicative of what we got going on with our primary circuit on a coil, that would tell me that if that's actually an issue, should knock 2 cylinders out. It didn't quite feel like a 2-cylinder misfire, but that could just be my subjective analysis being wrong. But looks like we got somewhere to start. I'm gonna do a couple of restarts and just see what that pattern looks like. All right, so the pattern seems to be when you do start it back up. Right now we've got key on, engine off. I did clear codes, and we'll make sure that codes are still cleared. It kind of does the intermittent miss, and then so I'm gonna see how long it takes before it actually starts to run rough again, and before we actually set these codes again. So we'll fire it up. Right now it's an intermittent miss. I'm gonna keep it in read codes. Oh, there it is. So intermittent, that's interesting. Intermittent loss of camshaft position. That's weird. Okay, it just dipped. Read codes again. No cam signal PCM. Just gonna keep reading codes. But it's not a dead miss like it was before. It's just kind of slightly surging. We'll see if we can't get it to go to actually do its straight misfire like it was. Oh, there, no, not yet. There's still same codes in here. Still just surging a little bit. There's a miss. We could probably show you, I'm sure as soon as I get off the screen, we're going to have the issue, but let me see if I can show you the engine RPM of what it's doing. Let's just search for, I don't remember what it's called. No. Engine speed, there we go. And then we'll zoom in on this a little bit. Yeah, so like those little dips and then an overcorrection, and then it's just kind of dipping out, but not a straight miss. Let's see if we have any more codes. This part might be a little boring, trying to get this thing to actually run rough. I don't know. Apparently, we're gonna waste time on camera. I'm gonna keep doing this. If it shows up again like it did, I'll bring you back again. Still not a dead miss. This still just got an intermittent. Brought our oxygen sensors back up. I'm gonna throttle into it a little bit and see if these will smooth out or go to the full range. Overall, the engine runs pretty smooth with a couple small hiccups. Red and blue are our upstreams. Oh, there's a lean pocket. So it looks like we are getting our 1-volt switch, but not very fast. Let it idle back down. Still just sort of intermittent. Let's do a stab. So we can get them to go rich. Now we've got more of a dead miss. Yep, oxygen sensors went low like they did. Let's see if we got new codes popped. Boom, ignition coil 2 primary circuit. That's interesting. So that's different. We had ignition coil 1, I think, last time. I have to replay the video. So we've got primary coil circuit issues. That's interesting. That's super interesting. All right, at this point, I think we're gonna get as far as we're really gonna go in the vehicle. I'm gonna shut this down. We're gonna recap all these codes. I'm gonna pull some service info, and then we'll see what kind of testing we're gonna start with. All right, service information update. So we've got more or less 3 codes. We've got our P0340, a 1391, and an 0352 or 0351. When we had those 2 different key cycles, we had the primary coil, circuit 1 and circuit 2, whatever. So just glancing through service info, some interesting data there. So for P0340, the code description is no cam signal at PCM. The first item in the trouble tree for 340, the cam signal, no cam signal at PCM, says, note, an intermittent crank position sensor failure may cause a P0340 to set. So I don't know if that's bad service information. I don't know if the control strategy for DTC set criteria is trash with Chrysler, which, I mean, that's pretty possible. But it's interesting that it says that it could be a crank sensor could cause the cam sensor code failure. And as you read a couple of things that like the pinpoint test, it has you checking both for some of these. The 1391 code was defined as intermittent loss of camshaft position sensor or crankshaft position sensor. So that one could be either. The beginning of that one says, get in the car with a scan tool and it says to synchronize, where to go? It says choose the set sync signal function and observe the actual sync setting. So on a tool, we have a special function called set synchronization signal. So we're probably just going to try that first before we get the scope out. The last code, the primary circuit codes. This one is a little interesting that they put this in the trouble tree. I'm not used to seeing this in a trouble tree, but whatever. It's helpful. The first step it has you do is check the ASD relay. So that could make sense. If we have an ASD relay that is intermittently sticking or unsticking, I'm going to take that back. I haven't pulled the wiring diagram yet, so you're listening to me brainstorm this live, which probably a disaster. But hey, if you're still watching, you're on board for the disaster. So initial thinking, if we have like an intermittently open closed in ASD relay, could that cause a misfire? For certain. Based on the tree, it looks like that's going to feed the primary circuits for the coils. However, when we have that dead misfire later, so like when the oxygen sensors drop straight lean and it's just constantly misfiring, it's not intermittent, that pushes me away from ASD power because that should kill power to all of them. Again, I haven't checked the wiring diagram yet, but just something to keep in the back of our mind. So I think those are the couple things we're going to, oh, and then for the rest of that, just as you like checking circuits and stuff, which we'll get the scope out and do. But I think our next series of tests are going to be the scan tool set synchronization signal, just to see what that does. And then we're probably going to start scoping cam, crank, and coil wiring and see what that pulls for us. In the car, fired up. We're going to hit our set sync signal function. Says it. Oh, that's interesting. It's bouncing back and forth between in and out of range. You see that? In range. Now it's in out of range, out of range, out of range, in, out. That's interesting. It's constantly bouncing around. Let me give it a little bit of throttle. Oops, I'm kicking all my cables. See what happens when we throttle it a little bit. Right now it's running very smooth and it says in range. Let's let it idle. Now we're back at idle. It's actually running really smooth right now. Well, this is interesting. We might be on to something. So if we remember, there it just dipped. There it dipped. And we're stuck at 8. Now I'm wondering if my data froze. Let's reopen this and see if our data froze. Yeah, now it's bouncing around. So it idled up just a little bit on its own there. Still bouncing back and forth. Let me throttle it again. So it looks like when we throttle it, it might freeze, tipping out. That's a little annoying. Got more tool glitches. One thing I've run into in the past with this is sometimes these special functions have so much data going over Wi-Fi that it freezes, and you have to USB connect the tablet to the VCMI to allow all that data to come through in a more reliable way, and it won't cut it out. I'm going to let this thing warm up for a while because it's still not, I don't think, quite at operating temp, but you're supposed to run this. That's pretty close, actually. You're supposed to run this at operating temp. I'm going to let this run here for a while and see if it starts to mess up, and if it does, we'll see if this screen changes. So we're bouncing in and out of range. Looks like 10 is out of range. Every time it hits 10, it goes to out of range. So, yeah, we'll just watch this, and if something happens, I'll bring it back then. So, slightly interesting development. It appears the cooling fan doesn't work. As we were running, watching sync state stuff, heard the a ding on the dash. We got to check gauges live. Coolant temp was kind of high. Let me flip you around. So no fan was running. We got a stiff radiator hose, and our coolant is boiling over on the ground for us right now. So apparently she's hot. So we've got we've got a couple things going on with this old girl. So might have to make an interim diagnostic for this cooling fan so we don't blow this thing up. So that's we're gonna let this thing cool off for a minute, and we'll keep coming back with you. All right, we are scoped in at the PCM connector. We've got channel A on our 5-volt ref, which is shared between both cam and crank. We've got B on cam sensor. We've got C on crank sensor and D on sensor ground. All of the grounds are going to battery ground. So we'll give this thing a crank and see what she looks like. Oh, and to let the engine cool down, if you pay attention to the beginning of the video, we just turned the lights on and it cooled right off. So let's fire this thing up and see what it looks like. Running fairly smooth. It's not really running rough. Let's shut that off, pause this. I'll get zoomed in on a couple of these and see how ugly they look. Well, already I can see some very odd issue. We might be onto something. What is going on? Okay, so channel B, green. Channel B is our camshaft position sensor signal. So we have a scope glitch, or we got to recheck this, because check this out. We are, this top, I don't know if you can see that, this top number on green has 23 volts. And it is capping it. I think I set the scale at 10 volts, so it's capping it. So it's going even higher than that. Why in the world would our, what's it, channel B camshaft sensor be going to 20 some volts? That's super weird. Let's zoom in and see what we got here. Pretty terrible at doing this all at the same time while filming. Looks like I have a bad scope connection on red, which is our 5-volt. Yeah, so I probably got a bad connection there. So what in the world's going on here? So we got to pull down to about ground, and that looks, buddy, if I didn't know any better, I'd say that looks like an ignition fire event. Does it not? Oh man, look at this. Let me zoom. That almost looks like a spark line. No way. Oh, buddy. That, oh, look at this. This is crazy. Okay, our blue channel, channel C, is the crankshaft position sensor signal. Look at this ramp, time aligned with this. Guys, I have voltage probes hooked up to the engine controller, not a current probe. That looks like a current ramp, does it not? Buddy, that looks like a current ramp. That's bizarre. I think we're getting somewhere. Look at this. Everywhere. So overall, blue again, channel B. Oh, excuse me, I misspoke. Blue channel, channel C is crankshaft position, and we're getting a normal square wave, but embedded in the square wave are current ramps. What looks like current ramps with this. So that to me looks like we've got some sort of wiring interference or short from the ignition system to our cam and crank circuits. That's bizarre. I've never seen anything like this. Um, I got no idea specifically where I'm going to go next. This is pretty weird. This is pretty cool, but man, if I didn't know any better, I'd say those look like firing lines on the sensors. That's pretty weird. Um, I'm gonna pause this and think for a bit, and I'll probably rerun the same test. I'm gonna try to get channel A, get a better connection so I can see 5 volts there. Um, that's pretty bizarre. Yeah, I'm gonna have to think and come back to you once I have my next test step. But that's pretty cool. I think we're on to something. All right, I just ran the same test that we just did inside, but now I got a channel A red on the 5 volt line. And this is pretty interesting the way this is working. So this event here, I just keyed on and then got this, and then I started it. But at key on, let me select red. At key on, we get about 10 volts. Move that out of the way. So this here is about 10 volts. And then if I zoom in to this trace, the pattern looks the same as channel B. Looks like it has firing events, but it's averaging around that 10 volt line. So if I put this there, so 11.6 volts, that's a weird number. Channel B that's interesting. So channel B's at 13 volts. So same pattern. I'm starting to think we got a copper to copper short in here somehow. I don't know how this thing's running. Like, I have no clue what's making this thing run. This is super bizarre. Yeah, I don't know where I'm gonna go next. I need to stare at some diagrams and look at some harnesses and whatnot. I should have left the camera on for this, but I really didn't know where I was going next. Let me flip you around and show you this. So we were plugged in back there at the engine controller with all our scope traces. Channel A was on our 5 volts at the engine controller, orange wire coming out. I moved channel A from that 5 volt spot at the engine controller down to the 5 volt at the cam sensor down there, and then I keyed on. When I keyed on, so this is my key on event, now I'm sitting at 5. Let me touch red, bring my cursor up. Boom, 4.8 volts. So it looks like we have good 5 volts at the cam sensor, but not at the engine controller. So I'm going to replay this, and we're going to walk over here. It's probably super shaky and whatnot. So I'm going to go ahead and crank it. So we are keyed on right now. We can see, we're about, looks like position 1, whoops, 4.8 volts. So let's go ahead and crank this and see what happens. I'm going to escape that. So definitely getting some noise in it, but not like it was. So let's go back to the engine. This is probably super loud. All right, so it's loud and shaky. You're just going to have to deal with it. So right now, channel A is plugged in the cam sensor. I'm going to unplug it from cam whenever this resets. Only the greatest film work. So I'm going to unplug it, or unhook the channel A. So we get our drop to 0, which makes sense. I'm going to plug this back into our 5 volts at the engine controller and hit the camera at the same time. So trying to get it into 5 volts. Boom, there's 5 volts at the engine controller, or the 5 volt ref. So that's what we're plugged into down there. I'm holding it in. Going back. Now we'll do the same wire down here. So 5-volt ref on cam sensor. You probably can't see anything. I hope you're not here for high production quality because I sure don't really know how to do this very well. All right, so we're going to try and get this in there. So we're still reading 0 volts. We're not in yet. Trying to work this in. Can't get it in. Boom, there we go. So there's our 5 volts there. And I pulled it out. We're at 0 volts. I don't have any idea how much you could hear or see in that last clip. I'm certainly not a camera aficionado. I'm doing good just to knuckle drag my way through this and get screen recordings and stuff. But looking at our wiring diagram, I don't know what you can really see. So our 5 volt from the engine controller, I don't know if you can actually see it this way or not. We'll try it. From the engine controller goes to a splice. This splice 105, and then we were down here at the cam sensor, pin 3, and we have 5 volts here, but we have a lot of weird voltage here. So I think at this point what I'm going to do is just start splitting that harness. I don't see what else I can really do. I'm going to think about this for a bit, but I don't really know what other tests I could do. Like, I guess we could ohm it. We could open it on both ends. That 5 volt runs everywhere there. I have to unplug everything to be a true test. Yeah, but to have weird voltage at the engine controller and a legit 5 volts at the sensor, that tells me something in between. And there's no other connectors here other than that splice. It says there's no other connectors there. We have to have some sort of problem in between those 2 points. I cannot think of another explanation on how we have 2 different voltages essentially on the same wire. It starts making you think. So if we have 2 different voltages on different ends of that same wire, that also means it should mean 2 things. So I'm hypothesizing live. Maybe I'll be totally wrong and whatever, but doing this live thought process, we have 5 volts at one end and we've got our 11 whatever with weird noises on the other end. 2 conditions have to be present. 1, there has to be an open between those 2 points. 5 volts cannot exist where the 10 volts over here and the weird signals exist. So there has to be an open in the middle. Condition 2 that has to be present is more than likely wherever that open is between the 2 points, there has to be a copper to copper short in something else. So naturally we're going to look at points of vibration and heat on this harness. But I think as far as I can come up with, I don't see anything else that it could be between these 2. It's interesting though, if we remember the codes that we're getting obviously cam crank sensor stuff. We're also getting that primary circuit fault for the ignition coils. And to see what looks like ignition coil patterns in the sensor circuits at the PCM, that leads me to think we're shorting across between ignition system and cam / crank sensor circuits. To that end, I think that's where I'm going next. I'm gonna ponder this for a minute, and I'm probably just gonna start pulling through this harness a bit, but I'll bring it back if and when I find something next. Well, at this point, I am a little perturbed. I don't know what I did in my last series of tests, but I'm not getting the same scope readings that I was previously with like ignition waveform traces. I didn't get into the harness yet. I was rechecking scope connections, and now I get a different pattern, and it doesn't exist. I'm wondering if I didn't push that back probe pin too far in. Maybe it went all the way through and touched another pin inside. I don't know, but it doesn't look the same now. So we got a little bit different of a setup. I did run one test. two tests off camera, so we'll catch you up. A little bit different of a setup now. So red is going to be our 5 volt, and then green is going to be our cam sensor signal at the engine controller. Blue is going to be crank at engine controller. Yellow is what I've moved. Previously it was on ground, sensor ground, and now I've moved it to the cam signal wire on the cam sensor. And when I record all this, we've got one channel on the crank sensor. We've got two channels on cam sensor at both ends of that circuit, so PCM side and sensor side. But when I actually record this data, flip this around, this is what we're getting. I'm getting a perfect square wave every time, and this is on cam and crank both. And I don't know why we're getting that same type of signal on both. We should not have that. Even if I zoom out pretty far, there's no skip teeth in here either, like I would expect to see. Certainly it's possible that either the cam and or crank sensor doesn't have a skip tooth somewhere in it, but I would expect to see a skip tooth. And obviously we're not going to have the exact same waveform on both cam and crank at the exact same time, which is what we have here. They're all low together, high together, all low together, all high together. So the other test that I did was I started up and I unplugged the cam sensor. I wanted to see what my yellow trace did, and then everything flatlined and the engine died. So it seems like it might be running off the cam sensor at that point. But what I'm going to do is I think adjust our channel C, so our blue, which is crank at PCM. I'm going to change that to crank at the crank connector and retake this capture. Today is a different day, and after getting a little frustrated with my scope readings, I don't know exactly where I left off of on the last video, but having some different patterns, what I was able to reproduce my different patterns, and I don't know what's happening. When I go and back probe the actual connections at the PCM, I get all the weird patterns. I get the perfect square waves. I can get the ignition traces on circuits I shouldn't have ignition traces on. I don't know. If you've watched any of my scope videos, we also know that scope can cache some data. So I've cleared that out, and I switched, instead of back probing, because I was getting too many variables back probing, I switched to Phil's probe on the important circuits. With the Phil's probe, now I'm getting clean data. The cam waveform looks like a cam waveform. The crank waveform looks like a crank waveform. I also scoped the primary circuits of the 3 ignition coils. Those look like they're supposed to, with some exception that we'll get into. But just catching you up, I did a bunch of stuff off camera last night, getting frustrated, and we'll do my best to catch you up on where I'm at now. Vehicle still isn't fixed. It looks like we might be looking at a crank sensor issue still. I know it's what we started with because it's had so many. But I'm going to spin this camera around and I'm just going to show it on my computer. I got some screenshots and some piston chart overlays and whatnot. And after taking a bunch of recordings and looking through this data in fine detail, I finally picked out the hiccups. And it's an interesting one. It's an interesting timing for the hiccup that I haven't seen before. So let's flip this around and I'll do my best to articulate my way through this. So we're looking at here is a screenshot, and I've got the 3 coil packs scoped on the primary circuit. Channel 4 yellow down here is our current ramp. Firing order is 153624, and I'm going to draw your attention to the first half of the screen. This is normal. This is what I'd expect to see. We got, 1 coil per 2 cylinders, so we've got cylinders 1, 5, and 3 firing, and then we go back to same coil and fire 6, 2, and 4. This is what most of the data trace looks like when I do this pattern. Occasionally when we get those small hiccups that we were recording previously, or just a small misfire, small bump, when I get those, I would start to see these events. I'm getting double strikes. Not only am I getting double strikes, the timing changes. So if you just, I don't have rulers or anything to pull on the screen, but if you just look at the gap between here and here, here and here, here and here, they're very evenly spaced. And so we'll call this, I don't know, on the screen it's like an inch. So like an inch between cylinder 1 and cylinder 5 firing red to green. Here you can see we have what looks like a quarter of an inch between cylinder 1 and cylinder 5 firing red to green here. And then this one looks close to being normal, but again, time-wise, where this blue trace is actually shifted a little bit to the left, and then here's a normal strike. And it does this over and over, and we can see that so it has new ignition coils on it that came with them, and the coils look fine. I zoomed in on this on the scope, and I don't see any vertical lines, so it doesn't look like any of these are shorted. But this double strike, this is a control strategy. The computer is firing these spark plugs out of the correct engine position. So this is where, after I got my good readings with the Phillips probe, what we started to come back to. And so I then went, okay, now let's reset a little bit. I know I've been chasing my tail real bad on this one. I probably named the video something like that. But I got a couple red herrings and chasing my tail. But this is where it seems to be coming together finally. So if we have the PCM on purpose firing these out of engine rotation position, out of the correct position, firing early, etc., and double striking, then either computer's just, bad, but that's probably not the case because they had this same, I spoke to the owner after I stopped recording yesterday, and the symptom is the same. So this is the symptom they had before it got all the work done previously, and then it got all the parts replaced, and it still has the same symptom. So ruling out an engine computer for that purpose. But we know that crank sensors will control, obviously, spark timing. So now I'm going to shift to another scope pattern. Let me bring it over to this screen. So here what we're looking at is I just went cylinder 1 or coil 1 with channel A. Channel B is going to be camshaft position. Channel C, blue, is going to be crank position. And channel D is actually just a repeat of cam, but at the engine controller. So one's at the cam sensor, one's at the engine controller, but same trace. So we got the same pattern. We have normal strike, normal strike, normal, normal, and then we've got a double, and then we've got a triple. What I don't have a great pattern for a screenshot anyway. So what I would do is I would look, I don't know if I can zoom into this. We're going to try. So, but on the scope trace, I would go to these triple strike areas, and I would zoom in real far on these square waves, and they were perfect. And I did this over and over, and I could not figure out, this is one thing that started to make me question an engine controller. There's a little bit of noise on it, but these square waves look perfect every time I get a weird strike or a multi-strike when I'm not supposed to. Like, I have no difference. I literally overlay the traces from a good recording or a good cylinder firing event and a bad cylinder firing event. There's no difference in the cam waveform. There's no difference in these they're actually empty slots in this tone wheel, and there's no differences there. There's no time shifting. They all happen at the same time. It's pretty confusing. But then what I started doing, so I started going through the blue lines in further detail. This is where it got trippy, and I don't know that I have a great screenshot. I'll find it here in a minute. What I found is, so follow me on this. For each individual red strike here, that is 360 degrees of crankshaft rotation. So that means every other is 720. Got that? What I would see is any time, and also in a normal world, these plug strikes would happen about in the middle of the cam low side. signal and about in the middle of the cam high side signal. So we can see that here. About in the middle, about in the middle, about in the middle, about in the middle, just like it's supposed to be. When I find the one that is wonky, like this one, and I go down and I actually go back 360 degrees, that's when I find an anomaly in the crank signal. So I didn't prepare this very well. This third square wave is actually elongated. It has more time duration and it regrounds in the middle. So let me pause this video. I thought I had one of these pulled up and zoomed in. Let me grab that. So we moved over to the scope because I actually saved the waveform file and I didn't put it on my computer. But so this is what we got for normal, same pattern. And if you'll notice, like all of these, when I've got normal events, these crankshaft square waves look real good, whatnot. My phone battery is dying, so I'm going to have to try and hurry through this. So those look normal. But when we go to the next screen, so the continuous recording, there's my double strike. And if I look at the double strike waveform, they look fine, they look perfect. But if I go back 360 degrees of crankshaft rotation, boom, that's an issue. So not only is this not normal, I actually pulled this crank sensor out, stuck a borescope camera in the crankshaft position sensor hole and barred the engine over and looked at that tone wheel, and that tone wheel does not have any weird things like this. It has four perfectly spaced hole slots in that ring, and I even stuck my finger in there with a bar on the crank bolt and barred it back and forth. There's no free play in it. It's not rattling. It's not loose back there, physically mounted. This is a bad crank sensor signal. So it looks like those guys previously were on the right track with the parts they had. This part is on back order from dealerships, but I did find one all the way on the other side of the country. So we're gonna talk to the customer, show him this, and then and see if he wants to authorize that actual Mopar part. It's a pretty pricey part. They're pretty proud of it, but every time. So this is just one event. Hopefully my phone doesn't die. Here's another one. So let's go here again. So this is another screen. And you can see, boom, we got that goofy pattern there. And 360 degrees later, we got a double strike. Let's go to the next one. So this one's clean. Next screen. Here's a double and a triple strike. So if we start on the good one, there we see that problem. 360 degrees later, we have a double strike. But also look, we also have an issue on this this section or this rotation of the engine as well on the crank sensor. And so again, 360 degrees later, we have that issue. This one cleaned up, so 360 degrees later, it looks good. So clean pattern, 360, and it goes back to normal. So this is what I'm seeing over and over. And so with this many strikes, I'm going to call another crank sensor just like the guys before me did. We'll talk with customers, see where we want to go from here, and we'll bring you along as it develops. The saga continues. So yesterday morning, I found one OEM crank sensor in the country, and it was all the way on the other side of the country. By the time I spoke to the customer, got his authorization approval, and called that dealer back, they had sold it, and the dude literally walked out with it. So now we're on a hunt for some other non-OE premium lines. We got a sensor. We're going to throw it in here and see what type of reactions we're going to get. We'll scope everything just like normal, and hopefully one of these other, premium aftermarket brands is going to do us a solid, but we'll see what happens as it comes. All right, we're in the vehicle. I didn't want to film this because I wanted to pay attention to the start without having to look through a screen and ever, but been running for a couple minutes here. All the traces look good. It's not misfiring. We're looking solid. All of this is still clean. We're not having those weird, crank patterns. We're not having any double or triple strikes, so that looks really good. As a total side note, if you guys ever got to do one of these, they're kind of fun, but you can actually access that crank bolt right through there. So that was how I got that bolt tightened. You can get it out pretty easy from underneath, but to get it back in, I had to pull that cover out and stick a swivel and a socket in there to get it threaded back in. But this is looking pretty good so far. So far, we're calling this a fix. I'm gonna watch this for a bit longer, and we'll bring you back here after a while, after it finishes warming up, and probably after I take it for a test drive. Suppose I should film an official closing to this video. That was it. It was fixed. I didn't have any problems. Let it idle in the shop for a few hours. Did a couple hot and cold cycles. Took it down the road. It's fine. Customer came and got it. They're not having any issues with it. So I don't know what caused wherever it was at previously to have to put so many sensors in it. I was trying to rationalize that and figure out what might be a cause. The only thing I could come up with, I've seen this happen like once or twice in the past. It's not very frequently, but when you're putting in sensors that are going by a tone ring, there's usually like the normal spec I seem to see a lot is like 30 thousandths of an inch between like the sensor and whatever tone wheel piece is going by it. There should be like a 30 thousandths inch gap. In that one, it's like a solid plate mounting around the flywheel or next to it or whatever, and it's got window cuts in it. I suppose it's possible because the sensors for this vehicle have that little paper spacer, that 30 thousandths paper spacer on the bottom of it to set the depth properly. It's possible that, one of the sensors that was put in previously could have been put in on a window. Maybe the gap was incorrect, but based on the notes that I got from the work that was done previous, I don't see how we could have that happen several times in a row. And the customer had said it was always, it'd run for a couple of minutes and then start having an issue again. So I really don't know what is the cause of that one from previous, but it's working now. That's all I got really in this video. Hope this was helpful to someone, but got to watch me chase my tail for a while. That was sometimes it's embarrassing, sometimes it's funny when you look back on it and just laugh at yourself. It's about all you can really do. But at the end of the day, car's fixed, and that's what really matters. So that's all I got for you. I'll catch y'all in the next video.